Hello everyone, welcome to my YouTube channel. Here, we will learn mathematics about geometric sequence. First, let me introduce myself. My name is Putu Nesya Pundiwanti. You can call me Nesya. I'm from class 4B Mathematics Education. With my identity number is 211-3011-029. Now, in this video, we will learn about some materials. There are the geometric sequence concept, how to find the nth term, how to use the formula for a geometric sequence, and the last one, how to solve problems using geometry. Okay, first, we will learn about geometric sequence concept. Have you ever heard about geometric sequences? A geometric sequence is a special type of sequence. It is a sequence in which every term except the first term is multiplied by a constant number to get its next term. To get the next term in this geometric sequence, we must multiply with a fixed term, known as the common ratio. And to find the preceding term in the sequence, we just must divide the term by the same common ratio. A geometric sequence common ratio can be negative or positive, but it cannot be zero. Let's learn together. If we take an example, we observe the multiplication of bacteria. At 7 a.m., the number of bacteria is only 1. Then, at 9 a.m., the number of bacteria is 2. And the bacteria are getting more and more. At 11 a.m., the number of bacteria is 4. How many bacteria at 1 p.m.? So let's pay attention. The bacteria multiplied by 2 bacteria between 7 a.m. and 9 a.m. to 2 bacteria. And from 9 a.m. to 11 a.m., the bacteria also multiplied by 2 the previous number, which is 4 bacteria, and so on. So every 2 hours, the bacteria doubles or it multiplies by 2. Now here is the geometric sequence. So what is a geometric sequence? A geometric sequence is a special type of sequence where the ratio of every 2 successive terms is a constant. This ratio is known as a common ratio of the geometric sequence. In other words, in a geometric sequence, every term is multiplied by a constant, resulting in its next term. So, from the bacteria growth problem, we can write it as a geometric sequence that is 1, 2, 4, 8, and so on, with a constant ratio is 2. The ratio between consecutive terms in a geometric sequence is always the same. If we multiply or divide by the same number each time to make the sequence, it is a geometric sequence. So the point is the common ratio must be multiplication or division constant, and it can be used to predict future numbers of patterns. Let's see another example of a geometric sequence. The first example is 3, 6, 12, 24, 48, and so on. The common ratio in this pattern is 2. Based on this information, we can say that the following 3 terms will be 69, 192, and 384. And the second example is negative 4, 2, negative 1, a half, negative a quarter, and so on. The common ratio in this pattern is negative a half. Based on this information, we can say that the following 3 terms will be 1/8, negative 1/6, and 1/32. If you want to find a term in geometric sequence that is far into the pattern, we have to use a formula. Geometric would start with a number. Let's refer to this number as A for now. In this case, there is a set amount of ratio that is always being multiplied on, whether the number is negative or positive but not 0. We can refer to the ratio as the common ratio, and we will denote it as R. This means that our second term would be A times R. Now, from here, our third term would be A times R times R. And notice that we can simplify this. This here can be simplified to A times R squared. But if we look at this number here, it seems to always be trailing behind by 1 from the term number we are on. So from here we got the formula. So the formula for the geometric sequence is AN equals to A1 plus R to the power of n minus 1, where AN is the answer term you are looking for in the sequence, A1 the first term in the sequence, N is the ordinal term you are looking for in the sequence, and R the common ratio. Now, at the first glance, geometric sequence might seem very similar to the definition of an arithmetic sequence. But the key things to note here is that the arithmetic sequence uses word difference, while the geometric sequence definition uses word ratio. The term difference here relates to a constant difference that can be either subtracted or added. Ratio, on the other hand, implies that we are looking at the involvement of multiplication or division. So, while arithmetic sequences has common differences as denoted by D as a key aspect that decided the difference between one term and another, a geometric sequence has a common ratio as denoted by an R. A common ratio is the ratio of any two consecutive terms in the geometric sequence. Now we will learn how to use the formula. We will look at an example shortly to make things clearer. Now let's put some natural numbers into this and look at this sequence. We got 1, 10, 100, 1000 and so on. It's clear to us that we are not looking for a common difference here since, as you can see, there is no constant number that goes up by instead. We are looking for a common ratio, which is the constant multiplication of a certain number from one term to the next. So if we pay close attention what is going on here, we can see that when we multiply 1 by 10, we get 10, and when we multiply 10 by 10, we get 100, and when we multiply 100 by 10, we get 1000, and so on and so forth. Therefore, our common ratio here is clearly 10, making the our value. And since our first term here is 1, we can also establish that as our A, so plugging in the following information so far gives us our base formula for this sequence. Now, all we need to do is plug in any term number into n to find the value of that term. So let's give our equation a go and double check to see if we can get the fifth term successfully plugging in 5 into the equation as n gives us the following, and simplifying this gives us 1 times 10 to the power of 5 of 4, which is just 10 to the power of 4, and computing this gives us t of 5 is equal to 10,000, which confirm our answer over here. Pretty easy, right? And if we had a sequence like this, let's bring back our formula and plug in what we know. We know that the first term is 5, so we will start the plugging that in, and we can also see that each term is a result of multiplying 3 with a previous term, so that makes our common ratio here denoted by R equal to 3. So here our geometric sequence formula. Alright, now let's try plugging in a few values in for n and see if it is a result that matches our sequence. If we plug in 3, 4, and we get the following. Now if we simplify this, we get 5 times 3 to the power of 2, which we compute first to get 9. Then do 5 times 9 to get 45. And if we look at our sequence, we see that our third term is indeed 45. Awesome. And what if we wanted to know what our sixth term was? What is value b? All we need to do again is plug 6 in 4n to get the following. Then we simplify the exponents first and solve for 3 to the power of 5 to get 243, and then compute this to get 1215 as the sixth term in the sequence. What kind of problem can be solved by geometric sequence? Here is the example. The first example is bacteria A multiply to double every 5 minutes. After 5 minutes, the number of bacteria is 14. The number of bacteria after 30 minutes is... Okay, we will answer this question. Let the first term represents the initial number of bacteria, the second term at 5 minutes, the third term at 10 minutes, and so on. From here, we know that the first term is A times R to the power of 3 equals to 400, and the ratio is 2. We will find the seventh term. By using the formula, we will get the answer. And we will find that the seventh term equals to 400 times 2 to the power of 3 equals to 400 times 8. And we will get the answer 3200. So we got the answer. The number of bacteria after 30 minutes is 3200. Now the next problem. Two children are doing a math experiment by dropping a ball from the second floor of their house. The height of the ball drop is 9 meters from the ground. From observation, it is known that the ball bounce reaches 8/9 of the previous bounce height. The closest height of the ball after 5th bounce is... We will answer this question. This case is a case of geometric sequence. The first bounce height is 9 times 8/9 meters. Thus, it is known that the first term is 9 and the ratio is 8/9. We will find the 5 terms and we will get the 5 terms is equals to 8 to the power of 5 divided by 9 to the power of 4, and we will get approximately equal to 5. So the height of the ball after the 5th bounce is approximately 5 meters. So the conclusion that we can understand is that there are some difference between a geometric sequence and arithmetic sequence. Geometric sequence is determined by the first term and the common ratio, while arithmetic sequence is determined by the first term and the common difference. In geometric sequence, the ratio between every two successive terms is equal to the same number, while in the arithmetic sequence, the difference of every two successive terms is equal to the same number. And in geometric sequence, the term form an exponential relation, while in arithmetic sequence, the terms form of a linear relation. And the last one, the sum of an infinite geometric sequence might converge or diverge, while the sum of an infinitive arithmetic sequence always diverges. Great! So that is for the lesson today. I hope you understand the concept, the example, and the use of geometric sequence. Make sure to practice some more questions, and until next time. Have a good day, see you, and thank you.